The star Betelgeuse, a red supergiant situated in the constellation of Orion, has long captivated astronomers and sky viewers alike due to its enormous size and brightness. If Betelgeuse were positioned where our Sun is, it would extend all the way to Jupiter's orbit, showcasing its immense dimensions. Despite the fact that it weighs approximately 642 times the mass of the Sun, it is 642 light-years from Earth. One of the brightest stars that can be seen with the naked eye. In recent times, however, Betelgeuse has displayed some peculiar activity, including unexpected dimming and brightening cycles, which many scientists believe may indicate that the star is getting close to dying. Recently, world-renowned physicist Brian Cox made a revolutionary statement that Betelgeuse is on the verge of a devastating explosion, which is anticipated to take place within the next 2 weeks. This event, known as a supernova, will mark the final stage of Betelgeuse's existence. Despite its imminent explosion, it will offer a remarkable opportunity for scientists to examine one of the universe's strongest and most spectacular phenomena. As a massive star nearing its end, Betelgeuse is classified as a red supergiant, one of the biggest and most massive types of stars in the universe. It has been under observation for centuries, but its recent erratic changes in brightness have sparked speculation that it may soon go supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under the immense gravity-driven pressure, causing an enormous explosion that releases an incredible amount of energy, radiation, and stellar material into space. Betelgeuse's imminent explosion is expected to be a Type II supernova, a particular kind of stellar explosion that occurs when the core of a massive star collapses. With this core collapse, the release of neutrinos and radiation creates a shockwave that disintegrates the star. The explosion will be so intense that it may even be visible from Earth without the need for telescopes, possibly shining brighter than the moon in the night sky for several weeks or months. While a similar occurrence would normally cause harm if it occurred closer to Earth, the distance between Betelgeuse and our planet, around 642 light-years, implies that, despite the explosion being visible and dramatic, it won't pose any risk to life on Earth. This event, however, promises to radically alter our perception of supernovae and cosmic phenomena. A supernova is one of the most energetic occurrences in the universe, releasing more energy in a short period of time than our Sun will release throughout its entire lifetime. Betelgeuse's explosion will not only be a dazzling celestial display but also an invaluable scientific event. Researchers are eager to monitor this rare incident from the very beginning, utilizing various ground-based and space-based telescopes such as the Hubble Space Telescope and the James Webb Space Telescope, JWST, to gather as much information as possible. When Betelgeuse explodes, it will emit a vast range of radiation, from gamma rays to visible light. One of the most important features of the supernova will be the flood of neutrinos, subatomic particles that seldom interact with matter. Neutrinos from a supernova can actually arrive on Earth before the light from the explosion itself, due to their capacity to traverse nearly everything without being affected. Observatories like Japan's Supercameo and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, giving scientists an early start in observing the final moments of Betelgeuse. Additionally, the explosion will offer crucial insights into the formation of heavy elements. When stars go supernova, they create and release substances like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will allow scientists to observe this process of creating elements in real time, which is vital for understanding how planets and the chemical makeup of the universe come together. Although Betelgeuse's supernova is not expected to have harmful consequences for Earth, it will likely interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the arrival of cosmic rays and charged particles, could produce more powerful auroras, expanding the regions in which the northern and southern lights are visible. While these cosmic rays could potentially interfere with satellite communications and some technologies on Earth, any minor disruptions are anticipated. One of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not only experienced astronomers with high-tech equipment, for weeks or even months. Betelgeuse is anticipated to be the brightest object in the night sky, and it may even be possible to see it during the day. This spectacle will not only captivate the scientific community but also spark renewed interest in astronomy among people who enjoy stargazing. Astronomers have long studied the cosmos and speculated about the death of Betelgeuse, whereas Brian Cox's most recent statement adds a sense of urgency to the situation. In the coming weeks, observatories around the world are preparing to study every stage of the supernova, and the data collected will be priceless, potentially transforming our comprehension of stellar evolution, core collapse, supernovae, and the distribution of cosmic matter. The supernova of Betelgeuse will also provide a rare opportunity to refine our models of the distances between the stars relatively close to Earth. It offers an unparalleled chance to observe how such an explosion's energy moves. By studying the light and radiation from the supernova as it interacts with the medium between stars, the gas and dust in the space between stars, astronomers will gain a clearer picture of the universe's scale. Additionally, the event will provide a golden opportunity to investigate dark matter and how it may influence supernovae. Dark matter, the mysterious substance that represents approximately 85% of the universe's mass, doesn't emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse's explosion might provide indirect clues about the role dark matter plays in shaping the universe. Betelgeuse's supernova will also bring us closer to comprehending the life cycle of stars, especially how massive stars play a role in the creation of the elements necessary for life. Supernovae are the primary cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even life. By studying Betelgeuse, scientists will gain important information on how these elements are forged and distributed. The cultural significance of Betelgeuse's explosion is profound, as humans have looked to the stars for direction, motivation, and inspiration for millennia. Most prominent stars in the night sky will prompt philosophical reflections on the transient nature of the universe. Betelgeuse has been a constant fixture in the constellation Orion for as long as human observation of the stars has existed. Its absence will serve as a powerful reminder of the impermanence of all things. In some cultures, such celestial events have been seen as omens or signs of cosmic change. The explosion of Betelgeuse may evoke a mix of awe, fear, and wonder as people from all walks of life witness a star's death. This extraordinary event will likely rekindle curiosity about space exploration and astronomy, drawing more people into the pursuit of knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows virtually anyone with a camera or telescope to observe and document the supernova. This democratization of science will unite people across the globe, all watching and recording the same cosmic phenomenon from their unique vantage points. Betelgeuse's explosion is not only a singular astronomical event but also a stepping stone for future space exploration. The knowledge gained from the supernova will influence how we study other stars, especially as we venture deeper into space with missions aimed at understanding other stars and planets. The life cycles of stars and the dynamics of supernovae are crucial as humanity looks to expand its presence beyond Earth. Additionally, the explosion will reignite interest in the search for extraterrestrial life. Supernovae play a vital role in distributing the elements essential for life, like carbon and oxygen, throughout the universe. By researching Betelgeuse's explosion, scientists can gain a better understanding of how life's ingredients could spread to other planetary systems and potentially spark life elsewhere in the cosmos. The impending explosion of Betelgeuse is shaping up to be one of the most significant astronomical events in our lifetime. In due course, its supernova will bring a wealth of scientific data, enhance our understanding of the universe, and captivate people all over the world. Though Betelgeuse's death will mark the end of a giant star, it will also symbolize the ongoing cycle of creation and destruction that governs the cosmos, a reminder that new stars, planets, and even life can emerge from death. As we await this monumental event, the world will be watching the night sky, anticipating the moment when one of the universe's most powerful forces bursts into view. For both scientists and stargazers, Betelgeuse's final act will be nothing short of awe-inspiring. As Betelgeuse approaches the final stage of its life, one of the more speculative yet intriguing possibilities is its potential to illuminate a few of the universe's greatest mysteries: dark matter and dark energy. These elusive forces are believed to account for the vast majority of the universe's mass and energy, yet they remain poorly understood. Some scientists speculate that supernovae like the one anticipated from Betelgeuse may hold the key to unlocking some of these mysteries. The extraordinary amount of energy and radiation emitted during the explosion may interact with dark matter in observable ways. One intriguing hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If they exist, their interaction with the energy generated by Betelgeuse's supernova could provide critical clues to their nature. Such a discovery would be groundbreaking, offering the first direct evidence of dark matter, an elusive phenomenon that has confounded scientists for decades. Similarly, Betelgeuse's explosion could offer insights into the nature of dark energy, the mysterious force driving the accelerated expansion of the universe. By studying how light and energy behave during the supernova, scientists may gather crucial information about how cosmic events like these influence the universe's expansion and how they might be connected to dark energy. The upcoming explosion of Betelgeuse provides a one-of-a-kind perspective on the life cycle of massive stars that are very important to the cosmic ecosystem. Red supergiants like Betelgeuse are rare, making their study essential for understanding stellar evolution. These stars form from clouds of gas and dust that collapse under gravity, eventually igniting nuclear fusion in their cores. As they exhaust their hydrogen fuel, they expand dramatically, shedding their outer layers through powerful solar winds. This mass loss contributes to the enrichment of the interstellar medium, paving the way for the formation of new stars. When Betelgeuse goes supernova, it will not only provide information about its own life cycle but also serve as a cosmic laboratory where the conditions under which stars live and die can be studied. Researchers will closely monitor the aftermath of the explosion to determine whether a neutron star or black hole forms at its core. The nature of this remnant will provide valuable details regarding the physical processes that govern the final stages of stellar evolution. The dynamics of the explosion itself will also provide a wealth of information. The shock wave produced by the supernova will sweep through the surrounding gas and dust, heating it and causing it to glow brightly. This emitted light will offer astronomers clues about the elements synthesized during the explosion, such as iron, nickel, and other heavy elements. By analyzing the spectral signatures of these elements, scientists will be able to determine their abundance and distribution, deepening our understanding of how these elements spread throughout the universe and contribute to the formation of future stars and planetary systems. Another area of interest is the potential for gravitational wave detection. As the core collapses, the supernova may generate ripples in spacetime that are observable by observatories like LIGO and Virgo. Gravitational waves carry information about the dynamics of the event, potentially offering new insights into the physics of supernovae and black hole formation. Betelgeuse's explosion could also be a driving force for technological advancements in astronomy. The anticipated surge of observational data will likely push the limits of current astronomical instruments, potentially leading to breakthroughs in imaging technology, data processing, and real-time analysis. These innovations could benefit a wide range of astrophysical studies beyond just the supernova. The involvement of the public will play a crucial role in Betelgeuse's supernova, fostering a sense of wonder and curiosity about the universe. Educational programs, outreach initiatives, and citizen science projects can use this event to motivate the next generation of astronomers and physicists. Schools and universities may organize viewing parties, lectures, and discussions that emphasize the importance of understanding the cosmos and our place within it. As we prepare for this monumental event, excitement is building throughout the scientific community and among amateur enthusiasts. The anticipation surrounding Betelgeuse's supernova encapsulates humanity's desire to explore the unknown, challenge our comprehension of the universe, and cooperate in our search for understanding. The end of a star becomes a profound reminder of the cycle of creation and destruction that defines the cosmos, urging us to reflect on our own existence and the beyond comprehension.